So far what we've covered deals with measurements, yeah. Because, oh, for goodness sakes. It's all good. All right, anyway. Measurements. Because in, science, we are supposed to do lab work and do measurements with lab work. I mean, that is the essential key to chemistry. Now, my predecessor, a chemistry teacher, didn't do very many labs at all. And the reason he didn't was somewhat valid, was nobody ever failed a chemistry course in college because they couldn't do the labs. He's right. Most of the really intense, good, fun chemistry lab work comes after you get your bachelor's degree in chemistry. And so at this level of chemistry, where we're learning our ABCs, our 1, 2, 3's, ABC, while we're doing all that stuff, it's really hard to put meaningful, productive, interesting labs into the curriculum because you're still learning how to, add and divide and multiply. Speak chemistry and learn why measurements and significant figures are important. All these little basics are building blocks to getting to do more cool, interesting stuff, and I'm going to do my best to get cool, interesting stuff in your hands. For instance, like you're going to be able to precipitate real 100% silver out of a solution. Absolutely. That's why I keep asking you guys to bring in empty pill bottles so that you have something to take it home in. But you'll end up, and so that's cool, right? Yeah. So I'm trying to get cool things into your hands, but to do that, we still need to work on the basics. And that's what this chapter discusses, basic measurement crap. Measurements always contain two things. What are the two things all measurements contain? Please, Taylor. Numbers and units, yes. Numbers we dealt with scientific notation. Why was scientific notation so extremely important? Yeah, because I'm too lazy to write all those zeros. How about you? We got a number coming up that you have to memorize. It's called 6.022 times 10 to the 23rd. How would you like to write 23 zeros after the number 6 every time?
Sure.
I'd forget a zero. And then trying to multiply and divide with that without scientific notation? All right, good. So then we went to significant figures, and why were significant figures so stinking important? Yes, ma'am.
They show people who are looking over your work that you know what you're doing.
Well, you're on the right track. It does have something to do with communicating your information. True. Yes, sir?
It shows your level of precision.
And yes, accuracy. It shows that level. Basically, you can only be as good as your crappiest measurement. And that's what sig figs allow us to do, is a set of rules that allow us to communicate how precise, accurate, or crappy our measurements were. Units. Well, we know every measurement's got to have a unit, and so that's where we're focusing today. Units. This is a unit. It's called a cubit. Do you think we use that very often? What's wrong with that unit? Yes, sir. Yeah. Everybody's cubit's a little different. That's a problem.
What was it used for, though?
Measuring distance. The length of a table.
Oh.
Okay. This is a unit. It's called hands. Use it to measure the height of a horse. You use it to measure from their foot to their shoulder, I believe. Withers. Is that where the lines are right now? On the withers?
Yeah.
Oh, thank you. Okay, so a hand. Declan, hold yours up. I want to buy a horse from him. Michaela, hold your hand. Michaela, hold your hand up. I ain't buying one from you. However, this unit has been standardized. We now know that 1 hand equals, who knows? The Mascot twins told me like that. Do you know? It's now been standardized. We now know that 1 hand equals so many inches or so many centimeters. It's now been standardized so Declan and I can sell the same horse for the same hand. Okay? It's been standardized. That's important. Foot used to be the king's foot. And when you got a new king, you got a new... what's the problem with this measurement?
Changes.
Oh, it's not
Standardized.
standardized. That's important. Oops, back. Oh, I guess not. What did that measure?
Thumbs.
The distance from the king's nose to the thumb. A yard. 2 points for you. Well, problem with that? Not standardized. Get a new king, you get a new yard. So if I was buying rope, you want to buy rope from McKaylee or Declan? Declan for sure. How about from Lydia? You want to buy rope from Lydia? Sorry, kid. If you were selling rope, who do you think wants to sell rope? Lydia or Declan? Lydia. Yeah. Okay, so we have these fundamental SI units. Standardized units. SI is French. Le Système du International. Anyway, a group of people got together and said, this sucks. We got to figure this out. We can't all be like talking feet and inches and cubits and have a worldwide community of scientists. This is not going to work. So they got together and went, okay, first we got to all speak the same language, hence chemistry. And now we all have to speak the same units. And America's still going, no, I don't think so. We're just going to use both. Sorry, kids. So the international, see that sign up there, that poster back there, it says International System of Units. Emergency? Okay. International System of Units. So that the entire world, my foreign exchange students come over, we introduce the International System of Units, and they're like, yeah, we got this. In fact, they can do it better than you because they use it for gasoline, and they use it for buying milk, and they use it for buying water, and everything they do is in the metric system. Not you guys. Yeah, both. I still don't know how we managed to get a 2-liter bottle into our common everyday language. 2 liters. It's metric. Still haven't figured out how America let that one get through. Why don't we use half gallons? I mean, that would be more consistent with the stupid system that we use. Oh, that might be a very valid reason right there. So, mass, length, time, and temperature. Put a big old star next to this. This table. Because when I say mass, and I don't know exactly why kilograms is it. I think it should be. I'm gonna change this. Take out the kilo. And take out the K. I want that. And then I'm going to add one more. It's the base unit. Grams is the base unit. So here I'm going to say name of unit, name of base. Because nobody asked me when they made this table, see. Name of the base unit. And then I'm going to add one more, volume. Anybody know the base unit for volume in the metric system? Whole? No, sir. But that's a really good guess. That would measure volume. Yes? Liters. How many of you ever play Boggle? Boggle. If you find the word liters, you can spell it the British way too. And get another word in Boggle. That's the British spelling of liters.
That's valid.
It's R instead of
Oh, it's
ER.
just
Yeah.
like color.
Yeah, color's got a U in it. Yeah, all right. Cool, huh? Okay, moving on. Oh, I should erase all my ink on the slide. Ladies and gentlemen, I'd like to introduce to you the International
That's thingy.
Standard kilogram. This is in France, in a vault under the Louvre. It is the world's most perfect kilogram. Reese, what you doing?
That's the most perfect.
Well, see, we had to have a standard. Couldn't be the king's foot. Certainly couldn't be the distance from here to here. We had to have a standard unit. Something off which all measurements could be based.
So
That is the world's most perfect kilogram, right there.
kilogram of what?
It's a metal with a very, very slow decay rate. Precise out to like 20 decimal places, 1.00000000 kilograms. That is
So
our
do they have,
standard.
Do they have like perfect like grams
That's-
somewhere?
Well, that's kilograms, so we don't need the gram.
Meters and
I don't know about the meters. That's a really good question. I would assume yes, but I haven't found it and I've looked. The interesting thing is there's some fun scientists who go, because atoms decay. How many of you ever heard of carbon dating, radiocarbon dating? It's how they like figure out how old something is based on the carbon atom decay. Well, there is some decay going on. And so it's out like 20 decimal places. So what do we do when that's, and how long will it take, and does this really matter? Good questions. Okay, moving on. Okay. All right, 1 kilogram is about the same as 8 sticks of butter. So if you hold 2 boxes with 4 sticks of butter, put like, you got a kilogram.
Okay.
So now you know about what a kilogram weighs.
okay, so 1 kilogram is 8 sticks of butter?
Yeah, see, 1, 2, 3, 4, 5, 6, 7, 8.
So what's the fifth?
Well, the conversion is 2.2 pounds in 1 kilogram.
So the fifth is like the other.
Don't worry about the fifth. I didn't make the slide. But you don't have to memorize this conversion. Okay? But just to give you a visual representation, if you want to hold a kilogram, put 8 sticks of butter in your hand. You got a kilogram. Okay. What's next? Oh, there's another visual representation of a kilogram. See, here's 1 kilogram of BBs, and it's equal to this many BBs. 2.2 pounds. By the way, I really like my weight in kilograms. Not that excited about it in pounds. Because it's, you know, a little more than half
Half of what?
what I weigh. So, for instance, if I weighed 400 pounds, don't you say anything, and I stepped on a scale, about, what would it read?
200.
I'd say 220. You gotta account for that 0.2 thing.
Hmm.
Yeah, about 220. So if I weighed 400 pounds, I'd be like, woohoo, look at that, I lost weight. All right, base units, you absolutely, positively, absolutely need to know these, absolutely. So, a meter, what is the symbol we use to represent a meter? Yes, ma'am. And what does this measure? Yes?
Length.
Length. I'd like to add something here. Yes, ma'am.
When we say like this, what's the pattern this
Yes, it does. 3 points. Excellent question. Now, I'm going to add another column
Why does it matter?
because a big M represents mega.
Yeah.
Okay, measures. I'm going to add another column, variable. Variable. How many of you know the equation to measure the volume of a cube? Oh, go ahead, Keaton. Oh, so volume equals length times width times height. So what variable do we use for length?
L.
L.
This is not,
the same thing as the symbol. The symbol
represents our unit. This represents the unit.
it represents.
The unit.
This is what you would put after a number.
Like 22 meters. Or better yet, how about the 50-meter dash? You could do a 100-meter dash. In track, who's in track? Do you use meters or yards? Yes! About time. When I was in school, they still used yards. So the meters is the symbol that comes after the number. But the variable is what we would put in an equation. Does that make sense? Okay. Grams. Darian, is that an emergency? Oh, my bad.
Sorry for assuming the kid was on their phone. Silly me. Grams, what is the symbol yes, ma'am. G. What does that measure? Yes.
Technically weight, but we can go with mass. And what is the variable you think we use to represent mass? This is confusing as all get out. Yes? Anyone? No? No? M. Well, because it represents mass. For instance, Newton's second law of physics says force equals mass times acceleration. Force equals mass times acceleration.
That is a variable that we would stuff into an equation. It is not the unit we put after a number.
For instance, there is 454 grams in a pound. That is what we put after a number, not what we put in an equation. It's not a variable. Liters. Yes, ma'am. Yes, it's capital L. Sometimes it's lowercase.
Why?
To make your life confusing. What does it measure, please? Volume. And what do we symbol for volume? Big V. Capital V. Little v is velocity.
Why can't they just like have different symbols like that?
Are you whining?
Yeah.
I'm sorry. Only if we ruled the world. This sentence you must commit to memory. I want you to say this sentence au détail. Au détail, I want you to say this sentence. Say it as you're falling asleep. As a little King Henry died by damn, I forgot my notes over there and I get up. No, really. How many of you have your phones handy? Right now. And how many of you will have your phones handy before you go to bed? Oh, goody, take a picture of that. So that if you're lying in bed going, what was Martin telling you to do? Oh, you have a picture of it. Where's your phone?
I'm too scared to not answer.
Yes.
I have an emergency. I don't have
Volume.
more than
Did I just have volume down? Okay.
it's not actually an emergency.
Where's phone?
Are you going to tell us if dog makes pigeons?
I haven't even seen it. No. Take a picture. Oh, that's it.
I said I'm afraid that you're close.
Did you dig it?
And
Sorry. Because she's just going to have to memorize it.
Why is this sentence so freaking important?
I think Henry died.
McKaylee?
The first letter of all of them are unit.
Yes! Each one of these represents a unit in the metric system. And this will help us convert from one unit in the metric system to another. This is only for metric system.
This won't do you a damn bit of good to go from like the system we use to the metric. No, those are stupid numbers. But if you're in the metric and converting to metric, this sentence is like all that. And a bag of chips. King represents kilo. H is hecta. D is deca. Bi represents your base units. There are 3 possibilities for your base units. Yes, sir.
Gram, meter, and
We'll get back to it. Yes. Drinking represents deci. Notice the upper and lower case letters. They mean something. Centi and milli. Now, the base unit again, Cole.
gram, gram, meter.
It's not crap. For goodness sakes. Yes. Grams? Yes, well done. So does everybody have that written down? Or photoshopped? I see photos coming out. All right. It's recording the video. Chillax. You can watch it later. All right, fine. Take a picture. I'll be patient. Yeah. Okay, so here we go. Base unit. One of the things you need to know about the metric system is this is based on the most awesome number ever. Pictures.
You need to know the system's based on 10. We got 10 fingers, we got 10 toes, it's 10. 10 is an awesome number. I don't mind to multiply and divide by 10, do you?
No.
5,280, that's another story. But 10 is a good number. Your base unit could be considered a 1. We won't always use a 1 for a base unit, but right now, let's say it's a 1, our starting point. Deca is 10 to the first bigger because it's based on the power of 10 and it's only 1 step away. Every step, notice I'm taking steps. Every step on the metric system is worth 1 power of 10. You know, no, you're getting one. And that, yeah, I get ants and it's really annoying. She brought in Smarties and I can't resist sugar. Ask Darian, we've been down this road. Here we go. But yeah, I'd prefer you not. Hecta then would be considered 10 to the second because everything is based on the power of 10. Every step is worth 1 power of 10. How many steps were there between the base and the hecta? 2 steps. Power 2. Anybody want to guess what kilo's going to be?
6.
6. Are you saying that just to be a smarty, or were you really thinking 6?
I definitely wasn't really thinking of it.
What?
I was being smart.
Oh, okay. Well, I was going to give you a smarty, but okay, yeah, have a smarty. Okay, here we go. 10 to the third. 3 steps. Give me 3 steps. 3 steps. See, you're here, right? 1, 2, 3. Now, you could go backwards. You could go backwards. And if I go backwards, I could be 10, but still power of 10, is it not? Is it still power of 10?
Yeah.
Okay. What's that negative sign mean?
Division.
Division. Good. Okay. What would centi be? And milli?
3.
Now, I am going to teach you a method by which you never have to deal with negative exponents. You like that method? I'm going to teach you a method by which all of your exponents will always be positive. And you'll never have to deal with negative 10 powers. You like that idea? Here's how it's done. My question for you today is how many meters are in a kilometer? Well, first off, what units are we dealing with in this question?
No.
Pardon? What units are we going to and from? Yes, Taylor. Yes, meters and kilometers. Meters I find in the base unit, yeah? Yeah, it's the base. Meters a base. Kilos way over there. Kilometers. All right, so still dealing with the question. Yes, ma'am.
Would it be like 300?
No, ma'am, but I'll get there. Good guess, though. I know why you said that. You saw the 3 steps. Okay, but be patient with that. Which unit is bigger? The kilometer or the meter? No, they're not. Kilometer's bigger. Notice, please, these have capital letters and these has lowercase letters. So which side's bigger?
Oh.
The capitals are bigger. And the farther you go this way, the bigger you get. The more you go that way, the smaller you get. You should write this down. The more you go this way, down this, up the scale, it's bigger. The more you go that way, down the scale, it's smaller. So I ask you again, which unit is bigger? Kilometer. Kilometer is like what we would use to measure a mile. A meter is like what we would use to measure a table or a 50-meter dash. So kilometers bigger. Always give the bigger unit a 1. So 1 kilometer. Oops. 1 kilometer equals. Always give the bigger unit the 1, and then you'll never have to use negative exponents. If you always give the bigger unit a 1, you never have to mess with negative exponents. Trust me,
Would
Paige.
you give it
I'll show you
I'm
what.
confused on why you would not do that. Like, why would you ever not give it a 1? That's what you're making, not like a conversion, but like that's what you're making it.
I understand what you're saying, but be patient with me. And you know what? If you don't understand why they would do that, it's okay. Because you know what? Give the bigger unit. I know, right? It does. So, how many powers of 10? Notice the word powers. Austin Powers. How many powers of 10? Because we know this whole system is based on what number? 10. It's all based on factors, not multiples, factors of 10. How many powers? To get there. 1, 2, 3. That was pretty good PowerPointing, wasn't it? 3. 1 kilometer has 10 to the 3rd meters. That's how you convert in the metric system. And everything, whether it's meters, grams, liters, it's all the same. Is our volume system the same? 1 gallon equals how many cups? I don't either. 12 inches equals how many feet? Oh, those aren't the same number systems, are they? They're completely different. 16 ounces equal, or how many pounds is to ounces? Ounces to pounds. Is it 16? That's not the same number system, is it? So in the English system, we've got length based on inches, feet, miles, with all different numbers. We have volume, cups, tablespoons, pints, quarts, gallons, all different numbers. Have nothing to do with the distance system, does it? And then we have a system of mass, yeah, pounds, ounces, completely different number system, and it's nothing like the other two. Yet here's a system that works identically for mass, volume, and length. It's exactly the same process, no matter what you got.
No, I'm not going to use a system. Metric system's stupid.
Oh my God. Here we go. This is our end game. This is what you will be capable of doing when I'm done with you, is to be able to convert 6 miles per hour to that many meters per second. Let's get her done. So all you got to do is you take your first unit, times it by your conversion factor, and you'll get a second unit, and you're probably going, huh? Right? Put it. I'm backing up to this slide. So you're done talking. Yo.
We're backing up to this slide, please, because
You, like all good scientists, are still at the very, very early stages of learning to multiply and divide, and add, and subtract, and spell. You're still at those very, very early chemistry stages, which makes it really hard to do fun and cool labs because you're still at the very early stages of your chemistry education. Still learning the basics. So, I have something cool coming up for you, where you will actually precipitate 100% real silver out of a solution, and you'll be able to take that silver home. That's why I keep asking for little pill bottles, empty pill, prescription pill bottles, so that you have a transportation device to take a little piece of silver home.
You've never asked.
Yeah, we never
Oh,
I could bring
I'm
you like
so
6
brave.
ibuprofen bottles.
I
I'd
want
like that a lot.
prescription bottles.
Oh.
Those orange ones. Yeah, just take the labels off.
Oh, okay, I got
Bring them in, please. I need those. Anyway, moving on. Okay, so moving on. In order to be able to calculate how many grams of product you will make in a chemical reaction, you need to learn a critical skill called dimensional analysis. I like to call it chasing your units down. And dimensional analysis, instead of starting out with units you've never heard of, like moles, that's a unit. It's not the growth on your aunt's face. It's not the thing that eats up your lawn. It's actually a unit, like a dozen is a unit. Instead of hitting you with dimensional analysis with units you don't know, we're going to use dimensional analysis for things like length, volume, mass, before we get you to some other levels. And this is a very basic chemistry learning step. Building the foundation of your chemistry career, which is what makes Chem so hard, is everything is like building block after building block after freaking building block before you get to cool stuff. I get that. So this skill that I'm trying to impart upon you is one that you will use all the time in chemistry. Am I right, Erica and Alex? Dimensional analysis, how often will they use this? Thank you. Even if they didn't know what I was talking about, they played along well. So this is the basic skill for dimensional analysis. For example, how many inches are in 2.85 centimeters? So, well, the first thing I like to do is figure out my conversion unit, and this is the only unit I will ask you to memorize. There's 2.54 centimeters in 1 inch. This is the only unit I will ask you to memorize. Now, if you're going from the metric system to the metric system, you got a sentence help you figure it out. King Henry died by drinking chocolate milk. And we'll use that a lot. But this is the only conversion between English and metric I expect you to memorize. Did you know this one already, Joy? Oh, good, now you do. About that long. 2.54 centimeters, about this distance for everybody, and it's also about the distance of an inch, give or take a little bit. It's about. Of course, it's not very standardized, is it? It's like a cubit, huh? Okay, here we go. The first step you really do is write down the number that's given. So in this problem, what number was given? 2.85, yay! Now to solve these problems using dimensional analysis, and yes, I know Mr. Baumgartner already went over this, but there was a request for me to do it again. You're welcome. Okay, a horizontal line. Now, can somebody show me where the horizon is? Like this? Oh, that's why that's horizontal. I know, some people are like, oh, wow. It's kind of cool. Fun to watch that look on their face, like, I thought about that. Okay. This horizontal line represents a fraction bar. Yes, and fraction bars are division, because if you look at the stupid division sign,
This one I call stupid because I never like to see it. I never like to use it, and I'm really irritated they teach it. But look, see this division symbol? Isn't that a fraction bar with the number on top and the number on bottom?
I heard didn't realize that either.
Gotcha again. You're like, oh, I see it now. Yeah, that's a division bar. That's a fraction bar, folks. With a numerator and a denominator, that's what it represents. Everybody's like, wow. How many of you were like, wow? No, yeah, I like that. It's awesome.
Definitely.
All right, and now a vertical line, and the vertical line is going to represent what?
Equal.
Multiplication. Pierce. You should write it down. This vertical line represents a times sign, aka multiplication. It is never an equal sign. Okay, now, the game to play is called Chasing That Unit Down. We're going to be chasing lots of units down. Show you what I'm talking about. See, oh, look, I chased it down. See, whatever unit's here, you're going to chase it down. You have never sat in my class before, have you? Sorry, you. Now, the next thing you want to do after you've chased it down is you can write down the unit you're trying to get to. Wonder what that is. Oh, yeah, it's inches. Now, all you have to do now, oh, wait, I got a question for you. What is, A divided by A equal? 1. So whatever's numerators on top and numerators bottom and the same, they cancel out, right? Oh, look. Numerator, denominator, goodbye. It doesn't matter. Look, dude. A over 1 times 1 over A is exactly the same thing as A times 1 over 1 times A, which is exactly the same thing as A over A. You okay with that?
Yeah.
Uh-huh. Better now?
Yeah.
Okay, good. Thank you for asking. That's a 3-point question right there.
Okay.
Now, I just need to put the conversion numbers in here. Now, these are equal statements. This statement has to be equal. How many inches are in a foot? 12. Is that an equal statement? 12 inches equals 1 foot? How many centimeters are in a meter? 100. Because there's 100 years in a century and 100 cents in a dollar. There's 100 centimeters in a meter. Is that an equivalent statement? 100 centimeters? Is that an equivalent statement? So your conversion units is an equivalent. Write this down. Equivalent. Did I spell it right?
Equivalent, yes.
Okay. It's an equivalent statement. I see kids all the time put things here that aren't equivalent statements. Don't do it! Please be the first class not to do that.
We'll try.
I appreciate that.
Have we spelled fluoride right so far?
Okay?
Have we spelled fluoride right so far?
No. Not in it. I get fluoride and I get I get the U missed entirely. Okay, so now we're the numbers into that ratio. So see that ratio right there? That 2.54 and the 1 go there. That's a pretty fancy PowerPoint, ain't it? Yeah. Who was Baumgartner? What do you
He didn't
think?
know what to do. He's like, what is going on? Why is this moving?
It's all good.
Squiggly lines.
Yeah, it's a step.
Yes, I don't want you to do that. Okay, going on. So I want you to take a look at this. I'll tell you why later. Stop that. Stop it. You done? Good. Now, I want you to notice that what I just circled is most often written mathematically in that purple. It means the same thing. It is a more efficient use of paper. It takes up a lot less space to write it this way. And some of you guys, and occasionally girls, with really poor handwriting, this will make your life a lot easier to do it in the way I've circled. And if you're going to Trine or Purdue, they do it this way too. Just to let you know. So now we need to simply multiply the 2.85, because times 1, hit enter, divided by 2.54, and you will get your answer. My answer has 2 problems right now. Michaela.
There was no more calculator.
No, you can use this one on my desk.
She can use mine.
And Whitney says you can use hers.
Wait, how did you get 1 point?
Take 2.85, times it by 1, hit enter. Then divide it by 2.54. I know, right? What? No, that's not the final answer. There's 2 problems with this answer. Kobe, what's the first problem with this answer?
It's not in the sig figs thing.
Yeah, how many sig figs do I need?
3.
Why?
Because there's the number with 3 left.
Yeah. We need 3 sig figs. One other problem with this answer, please. Yes, ma'am? What unit do I need? Inches. Questions? Okay, then let's try 1, 2. Here we go. Problem number 10. Please write this down. You don't have to write.
Can you do the test today?
After school? Well, it's not during. An Italian bicycle has its frame size given as 62 centimeters. What is the frame size in millimeters? So, what do you think? You think you can handle this problem all by yourselves? Do you want me to take you through it? I'll take you through the first one. Okay, so here we go. We're always going to start with what's given, which is 62. So you're to write 62 centimeters down. A really good idea for these is to make a plan. As these problems become more difficult, a plan will be so much easier. So our plan is to go from centimeters to millimeters. How on earth do we do that? Oh, we do need to know how many millimeters are in a centimeter. So is there a sentence?
George died by drinking chocolate milk.
King Henry
Henry.
died by... Okay, good. So that's... that's all right. So, where's centi?
C.
Okay. Well, I'm going to draw this line thing. What does that line thing represent? What's that line thing represent, Jordan? It does, and I really want to show you something. It's actually a fraction bar, but I want to show you something with that stupid, ugly division sign, which they would never, ever, ever use or teach. But have you ever noticed that division sign is really a fraction bar with a numerator and a denominator represented by dots?
Yeah.
You guys knew that? I know, right? Not very many people knew that. It was pretty good. Yeah, but I wish I wouldn't use it. But that's all it is it's a fraction bar showing you a number goes on top and bottom. Put your phone away. So anyway, so if centimeter, now we're going to draw a vertical line. And what does this vertical line represent? No, never. Never, ever, ever, ever. Does it even? No, it doesn't. Happens all the time. Equals. No.
Never.
What does it represent? Multiply.
Never son.
Okay, good. So the centimeters are here. What am I going to do with it? We're going to chase this unit down to down there. And what goes on top? Goody. So now, if you never, ever, ever want to use negative exponents, pay attention. Give the bigger unit the number 1. Which one is bigger? So I put 1 here. Now this entire system is based on what number, Austin?
62. 1.
Metric system's based on
I said 10.
I was wanting you to say it. They can't hear the Thank you. All right. Now, the only thing we don't know is the exponent.
So 10 always goes on top.
No,
Well, start with the smallest one.
10 always goes to the smaller unit. Yes. How many steps are there between milli and centi, please, Alex? 1. So our exponent is 1. Does anyone have any questions at this time?
No.
Stop with the flashy lights. So now you just pick up your handy dandy. Oh, look, centimeters canceled. Why could centimeters canceled?
Because there's no need for that.
Well, no, it's because everybody, what does A divided by A equal? 1.
Wait, how do you?
How do I what? Get A over A?
Nuggets.
You mean A over A doesn't look like this problem?
No.
Well, Cole, take a look at this. This problem could be written like this, right? Instead of 62, I have the number 1 times A over, because, you know, I'm replacing the centimeters, right? And then, here, let's just do this. We'll rewrite it. 62 centimeters times whatever divided by 1 centimeter. Don't those cancel? That's the same thing as the reason I canceled over there. Okay, good. So we're good with why they canceled.
Yes.
1's in the numerator, 1's in the denominator, and they cancel. Like I have A over A, which doesn't equal 0. It equals 1. So, what? No, it doesn't. Anything divided by itself equals 1.
So F divided by
1. Okay, so your final answer would be 620 millimeters. So glad you guys picked up your calculators and tried it on your own. Any questions? Some do. Any questions about this problem? Oh, you write power forward to another. No.
Wait, why'd you have one exponent?
Good. I had a question, so you're not talking. The question is, why is the exponent 1? When I look at this sentence, centi is here, milli is here, so there's 1 step between them. That's where I got the 1.
If you go left, is it negative?
If you always give the bigger unit the 1, you never have to use negative exponents, ever. Yeah. Any other 3 points? Any other questions? Mm-hmm. Any other questions? Okay. Water is often bottled in 16-ounce containers. How many kiloliters would this equal? We need a plan. The problem says to go from ounces to kiloliters. And I give you this conversion. Does anybody want to revise the plan? I need a plan before I do that. Yes, Christian.
Instead of 60 ounces, make it 1 ounce.
No, because this is fluid ounces, which is different than the other ounces. And truthfully, it should have said fluid, to be truthful. Yes, sir.
Convert kiloliters to kiloliters, liters. So that way it goes with the conversion.
So you want to go from ounces to, and then to kiloliters? That works. So what should we start with? What's given? Okay. So 16 ounces. Now we're going to draw our division bar. And then we're going to draw our multiply bar. Okay, so if ounce, yes, sir? You do watch, okay? You watching. If ounces is here, what are we going to do with this unit, Vincent? And chase it down. Yeah. And what am I going to put up here? And what am I going to do with these numbers? These numbers, James? Where do you went 1? Good. And down here? Good. Now, did that make the ounces cancel?
Yeah.
Is that the unit we want?
No.
Oh. Okay, what am I going to do with this liters now, Umberto? I'm going to chase that unit down. Chase it down, man. And what am I converting it to, Jordan? Good. Now, to convert from liters to kiloliters, what am I going to need to know there, Austin? King Henry. Died by drinking chocolate milk. Okay? Got it? King Henry died by drinking chocolate milk. Okay, so if we have that, yes. Where do you want to put the 1? Why do you want to put the 1 here? I mean, you're right, but why? Well, I don't care about that, but why do you want the 1 there? Yes. Kiloliters is bigger than a liter. Does anyone have a question for me right now?
Why didn't we put an exponent?
Well, we always put a number 1 at the bigger unit if you don't want to deal with negative exponents.
So we don't have to put an exponent?
Well, not on the 1, no. Never on the 1. It'd be pointless. It'd be pointless to put an exponent on the 1.
So why would we put 1 on this one?
We didn't put it on the 1.
Why would we put it on the 10?
Right, we're getting there.
We put it on
We're getting there. Vincent?
Winston?
Yes, liters is under the base. Good. Liters. What else goes under here? Meters. What else? Grams. Good. So, how much, and this whole system is based on what number, Austin? 10. So, what will our exponent be here, Kelsey? We're going from killi to liters. 3. Questions?
No.
Got 5 points for the question I'm waiting for. No, that's not one. Still waiting for the question. Yes? The entire metric system is based on the power of 10. So if the bigger unit gets the 1, the smaller unit will get the 10. 2 points, good question. That's quite the one I wanted, but it's good. Yes, sir. How do we get the 10? The 3. We go 3 steps. 1, 2, 3. Every step on the metric system is worth a power of 10. Two points, good question. Not the one I was after. Austin?
Okay, well, I have 2 questions. Do the liters cancel now?
Yes, the liters do cancel now.
And how are you supposed to multiply it like that? Because we're just equal 16.
Sure, I'll answer that in a second. That's 4 points for the total questions, not the one I wanted. Vincent? I'll show you what to do in a second. I'm still waiting for my question.
Why not just write 1,000 instead of 10 to the third?
Because when you get into that habit, when you get to like 10 to the 6th, it's easier. All right, so to enter this into your calculator, since I didn't hear the question I wanted, I'll move on. To enter this into your calculator, this is what I would do. I'd take 16 and ignore the 1s, because 16 times 1 times 1 is... And then I would hit the division sign. And then I would hit parentheses, 33.8 times 10 caret 3, and parentheses.
Wait, what is that, an N?
What
Is that an N?
is what an N?
Next to the 3.
Caret.
What is that?
On your calculator, you'll see it looks like a little hat thing.
Right underneath clear.
Oh. Wait, what?
It's like raised.
The E?
No, bring me a calculator.
Is it the H?
No. Might be the H. That one. So 16 divided by 33.8 times 10 raised to the 3rd. All right, so you punch it into your handy-dandy calculator and you'll get 4.7 times 10 to the negative 4th. Yes, sir. What do you mean, how's that right? The sig figs are correct. We never, ever, good 3 points, good question. Not the one I was really waiting for, but that's good. Never, ever, ever, ever use conversion factors to calculate sig figs. Sig figs come from original measurements, not definitions. Any other question? That was a good question, though. Any other questions?
Why do you put it in scientific notation?
It's easier than writing 0.00047. That's why. Choose whichever way is easier. Yes, sir? That's what your calculator should spit out. Any other questions? Because this problem is not right yet. You're going to lose.
For the item,
Oh, you have to put symbol.
what did you have to make the decimal?
No.
Unit?
Unit! Yeah.
I said that.
I know.
Wait,
Kiloliters.
can you go back?
Sure. Except it's gone.
It is?
I'm still waiting. Why couldn't I what? No. Because I didn't know the conversion from ounces to kiloliters. Do you?
No.
That's why. Okay, take a look at this one, please. The length of a marathon race is approximately 26.2 miles. What is this distance in meters? Oh, goodness. I guess a plan's in order. We need to go from miles to meters. Plans, guys, as the problems become more difficult, it's really important to pay attention to the plan because it will help guide you through these problems. So the conversion that I happen to know is this one. 1 mile equals 1.609 kilometers. I know this one. You don't have to, but I know because I'm old. Been doing this a long time.
You have to memorize it.
No, the only one you need to memorize is 2.54 centimeters equals 1 inch. That's the only one you have to memorize. 2.54 centimeters equals 1 inch. Because it allows you to convert from English to metric fairly simply. Okay, so anybody want to revise my plan? Well, my plan right now is to go from miles to meters, but I don't know that conversion. Yes, sir.
Miles to kilometers to meters.
Oh, I think that would work. Okay, so where should I start, Jordan?
First off, right, 26.2 miles. And then you want to make a division line. And then a equal multiplication.
Thank you, James. You want to go from miles to feet to what? Do you know how many feet are in a meter? No. There's 3 feet in a yard. There's not 3 feet in a meter. But if you did know that conversion, have at it. It's not that either. Okay, here we go. So if miles is here, what goes down here? Miles. And what should I put in the numerator there, Alex?
We put meters.
The plan doesn't say meters anymore. Yes. And so because I have the nice little conversion here, Austin, where should I put the 1.609? Yes. Peter, where should I put, then I'll put the 1 here. Yeah, then they cancel. Oh, look. What should I do to the kilometers, Peter?
Move down.
Chase it down, yeah. What should I put in the numerator then, Alyssa? Up here. What are we converting to? What's our plan say to do? We went from miles to kilometers, now what? Just the unit, honey.
Oh, you do meters.
Meters, good. Now, how are we going to figure this out, this conversion? What's that sentence again, Austin?
King Henry got the
By. Okay, good. Where on this is kilometers, Allison? Oh, the K? Yeah. And where on here is meters, please? Austin? It's in the base. That is meters. That's milli. This is meters, liters, or grams. All right, so what do I do? Where do I put Why am I going to put the 1 on the bottom? Oh, good for you.
10.
And 10 on the top. Still nobody asked. Okay,
Why do you put 10 on top?
because the system's based on 10.
Why is it based on 10?
Because that's how it was defined as the metric system.
That's why it's used.
Yes. Any other questions?
Will you give us a hint what the question is?
Soon. Yes, the kilometers cancel
Why
out.
do you have to, why do you have to
Why can't you put
Because what do you want to put instead of the exponent?
Why can't you put 10 on the bottom?
Because you always give the bigger unit the 1 and the smaller unit the 10, so you don't have to deal with negative exponents.
But he just said kilometers was bigger.
Kilometers is bigger, so it gets the 1. And the smaller unit gets the 10.
But you just said the bigger unit is the 10.
Sorry. The bigger unit gets the 1, the smaller unit gets the 10. Every time. Every time. Okay. So, using your handy-dandy calculators. Vincent? Well, how do you think? Yes, I would.
Which one do you have to put in parentheses?
Nothing on this one. It's all in the numerator. Okay, so what'd you get for a final answer, please?
14.55.8 meters.
Okay. So we have 42155.8 meters. Are we done? No, we're not.
What?
No, we're not. Aaron, what's wrong?
What?
Sig figs are wrong.
Oh my gosh.
Give me the right answer to the right number of sig figs, Deshaun.
4.22.
Really?
4.
4.22? I mean, that does have 3 sig figs, that's true, but you know, if my yearly salary was $42,000, you round it to $4.22, you and I are going to have a problem.
42 point. I don't know. Oh,
You mean-
okay.
Wait, Deshaun might have an answer here.
So it's 42,000.
So you want 42,000?
40. Yeah.
Like that?
Mhm.
That has 2 sig figs.
How many do you need?
42,200.
How many do I need?
3.
I need 3 sig figs.
42,200.
That'll work. Or, what's another way he could have done this, please, Riley?
42.
He was on the right track here, he just failed to finish it.
Wait, how do you know?
4.22 times 10 to the 4?
Yes. Either one of these answers was acceptable. Jordan, question?
Wait, how
Oh, sorry. Cole,
How do you know how many sig figs?
you go to the original measurement, and this has how many sig figs? 3. Stop.
Original.
40,000.00.
That's a lot of sig figs.
1, 2, 3, 4, 5, 6, 7 sig figs on that one.
What? Those ones are.
Trailing zeros count if there's a decimal point written somewhere.
Yeah, but what about the ones up to the 40?
They're written and they're trailing and there's a decimal point written somewhere. Okay. This is the hardest dimensional analysis problem you will see this chapter. And the trick is right here. The trick is this. See, that all looks like it's written on one line, doesn't it?
No.
And it is not. Do you see the fraction bar? So that problem is really 225 miles divided by 1 hour. Nah, just do it all in one. Make your life easier. So, which one do you want to tackle first? The miles or the hours? Sure, so if the unit's here, what do you want to do? And what do you want to convert it to?
How's making my life easier?
I'll show you.
Kilometers.
Yes. And I happen to know there's 1.609 kilometers in 1 mile, and that made the miles go away. And do we have the unit in the... Do you see this? This is actually kilometers per second.
No.
Yeah.
Okay, so now you want to do the hours? Where am I going to put the hours now? Uh-uh. I'm going to chase it where? Chase it up. Well, Kelsey, stop. Kelsey, they have to be on opposite sides of the bar to cancel. So that's why we chased it up. So how many hours, what do you want to convert hours to?
Seconds.
Sure. There's 3,600 seconds in 1 hour. Do you have a final answer for me, Jordan?
Why isn't there a 10 on top?
There's more in there for... Because we didn't convert from the metric to metric.
What is the metric to metric?
We didn't do like kiloliters to liters in this problem.
This is confusing.
Well, mostly because the Tweedle twins are being disruptive.
Cool. Through them thing?
Uh-huh.
Is that an S? Is that an S?
I was waiting for you to get defensive. What?
Is that an S?
Mm-hmm.
I did.
I know, it was fine. So what's our final answer, please?
I do have one.
Yes, sir.
Is there 3 or 4 sig figs in the original?
What do you think?
4.
3. 225 has 3 sig figs.
But the
Wait.
one on the hours then doesn't count.
Conversion factors never count.
How would you put that on the calculator?
Hold on, Riley, question.
Never mind.
You have to go with your original number.
Well, then there's a 1 on the hour though. Why does that not count?
The one isn't actually written there. Does that make sense? It's per hour. Good. I like that one. That was 3 points. That's a good question. Okay, so yes, sir. Mm-hmm. Now I need a unit, Charlotte. Why don't you put your phone away, honey, so you're not distracted? Away. Vincent.
First you put a bar on top of that.
Mm-mm.
Seconds.
Mm-mm. Unnecessary. Says that it's 0.100562. Oh, you want kilometers here? Okay, now what? Thank you.
How did you get that answer? In parentheses put 2.
Well, your calculator said 0.1005. Did you get that?
I still don't know how to put that on the calculator.
Okay, to put this in your calculator, you're going to take 225 times 1.609 and hit enter.
Yeah, I did that.
Now hit the divide sign,
Yeah,
3600, and hit enter.
did that.
Nuh-uh.
Yes, I did.
Bring me your calculator.
Wow, you get now, slam down
I got up and it moved.
Does it all the time.
your joke around.
You have 1.069, not 1.609. Yes, sir. I hope you can. 3, 2, 1, go. Oh, by the way, this number's 454, please. It's actually 454.56. I got carried away. And still you haven't learned. Is there anything else in there for which you can make a key? I think you can do the back of the study guide.
Yeah.
You don't focus very well when I talk. That's part of the problem.
No, I just don't know.
So it's going
I don't focus very well when I talk.
No, that's not it.
What is it then?
I don't know what do you want me to do? Like, I
Re-
can go from pounds
So
to grams.
on this
I
one,
just gave you the directions.
on this one, do we have to go from pounds to kilograms to grams?
Mm-hmm. No, pounds to grams to kilograms.
Why? Because grams come first.
Because they gave you the conversion between pounds and grams.
Oh.
So you want to know pounds at ounces. Alright.
Would the grams go underneath or
Chase your units.
they go on top?
Start with pounds, and then chase your units down. Look at your previous problems, Austin, and see if you can apply that.
Smallest goes on bottom or the biggest goes on bottom?
There's no rule for that. You just got to chase your units.
Oh yeah.
This.
Does that say 35?
Yeah.
No.
Yeah, you're right. It's going forward. Oh, wait, I gotta keep one.
3, Austin. 3, Umberto.
The kilograms go down here. And then go up.
Grams goes down. Chase that unit down.
And
3. Vincent. Yeah, that.
It's supposed to be a 2 on 9. I know 2 too.
Where?
9.
Yes, there is supposed to be a 2 on that. No. Your last conversion's wrong.
did I do that right? Or did
The bigger unit gets the 1.
How do I know which one?
That's the one I've been waiting for all day. All hour. That is the question. How do you know which unit's the bigger unit?
How many points is that?
5. Here we go. We'll make it 10 because it took all day. Here we go. All hour. King Henry died by drinking chocolate milk. Okay, so notice these are capital. And these are not. These are not. These are bigger. These are smaller. The farther this way you go, the bigger the unit. The more that way you go, the smaller the unit.
Why did you do that? There's no point of asking.
That was the question I was waiting for.
Oh, I think I'm.